Okay, hopefully the sound is working here. I'm making a video about the problems we did in class. And so I plucked 3 of the 5 problems out, and I'm going to go through them, starting with number 1. So 1 says find the equation of the plane through the point P naught 245 perpendicular to the given line L. Okay, so drawing a picture here. We have our plane. I'm going to call this plane M. Now we know the point P naught is on there. And P naught has coordinates 2, 4, 5. And we know that the plane is perpendicular to the line L, which has 5, 1, 0 as its beginning point, and then the vector v, which is 1, 3, 4 times t. Okay. And so we need the normal here, because remember, for a plane you need the normal or the tilt, and you need a point, and we have the point. So we're looking for this n. Well, we know that the plane is, we know that this is perpendicular to the plane, and we know that the line L is also perpendicular to the plane. So that says the line L is parallel to n. Is parallel to n, which means it's just a multiple of n. So we might as well let that multiple be 1. So here we go. We want n to be the vector 1, 3, 4. Right? Because L has this point 5, 1, 0, and it's parallel to the vector v, which is given to be 1, 3, 4. Okay, so now we have the normal, and we have the point, and we have the point 2, 4, 5. And so we put it into the standard equation here, which is what? It's 1 times x minus 2 plus 3 times y minus 4 plus 4 times z minus 5 equals 0. Cleaning that up, we get x plus 3y plus 4z equals, what's that, 2, 12, 20 equals 34. Final answer. Okay. Well, that's problem 1. Let's look at 3. Three says find a plane through the point that's perpendicular to the line of intersection of the planes given. So there's 2 planes given. So I'm going to let M be the plane 2x plus y minus z equals 3, and n is going to be the plane given x plus 2y plus z equals 2. Okay. So here, let's be careful. Here's M. Some color in here. Here's the plane N. Here's the line of intersection, L. Okay. All right, so somewhere out here we're looking for a plane. So we're going to find a plane. I'm going to call it Q. And we know that Q is perpendicular to this line of intersection. So here's the plane Q. It's perpendicular to this line of intersection. So that means L is normal to Q. That's the key here, right? So the line of intersection of M and N is normal to Q. And we also have what? That this point here, P naught, is in Q. So once again, we want to find that the normal to Q. So I'm going to call that N. And it's parallel to L. So all right, so N is going to be N1 cross N2, where N1 and N2 are the normals to the planes M and N. Okay, so N is going to be N1, which is 2, 1, minus 1, crossed with N2, which is, oops, not X, which is 1, 2, 1. And I did this before. Here. Where is it? It's 3 minus 3, 3. And to rewrite the point again, P is 2, 1, minus 1. Okay, so now we have the plane. So it's 3 times x minus 2 minus 3 times x minus 1 plus 3 times z minus a minus 1 equals 0. 3x minus 6 minus 3x plus 3 plus 3z plus 6 equals 0. And so that's 3x. Wait, that should be a y, sorry. 3x minus 3y plus 3z equals 0. And let's just clean it all the way up to that. Okay, that was problem 3. Let's do 4. Find a parameterization for the line effect intersection of the planes x, y, z equals 1. And the plane n x plus y equals 2. Okay, so for this, we need to find the line. So we need what? We need a vector that's parallel to the line or on it, and a point. Okay, and what's the vector? V, it's the cross. It's the cross of the two ends, so it's 1, 1, 1, crossed with 1, 1, 0. Whatever that is. Let me jump over here to my other computer and go to Symbolab cross product. Bring that up. 1, 1, 1, 1, 1, 0. Oops, 0. Go. Minus 1. 1, 0. Okay, so that's good. So now we need a point on the line. So I'm just going to guess and check here, because they're nice planes. X plus y is 2, so that means z equals minus 1. And I'll let x, hold on, x equal y equal 1. So we have the point 1, 1, minus 1. And just check to see, does that work on M? Yes. Because 1 plus 1 minus 1 is 1. And then over here, 1 plus 1 equals 2. Okay, so now we have the vector and the point. So to finish this off, the line has equations 1, 1, minus 1, plus, 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 minus t, t, 0 t. So that's 1 minus t, 1 plus t, minus 1. Okay, hope that helps.